How's it going? My name's Chris. It's time for another daily coding problem. Today's problem comes from the LeetCode top interview question list. I'm just kind of working my way from top to bottom there, trying to get better at these types of problems. We're seeing lots of patterns. Can already tell you that today's problem has something we've seen before. So let's read it. Given a collection of distinct integers, return all possible permutations. And then we have an example where we get three numbers in, 1, 2, 3. And we return all possible permutations, and we have 6, right? And from what we've seen in the other problems we've done, we can calculate the number of permutations as 3 factorial, right? Which is 3 times 2 times 1, which equals 6, which is how many we have here. Okay, so we've done a lot of permutation problems, but this one's specifically permutations and just printing them out, so this shouldn't take us too long, and I'm thinking I'm going to use recursion for this. So let's copy this example they've given us, and I'm going to write this in Ruby and start by creating a test. So let's do solution test, and I'm just going to use the example they gave us. So mini test auto run for running our tests, and then we're going to use mini test pride so we get color output in our tests, and then we need to require the actual file we want to test, which we're calling solution. And now let's describe what that looks like. We need a method, and we're going to call this permutations, and it returns all permutations of the numbers. And then they gave us an example here. So there's our input. Here's our output. This is what we expect to get back. So we want to assert equal this blob, and then solution.permutations of our input. And then let's fix the spacing, remove our blank lines. So this looks good to me. Let's go ahead and run our test. And it fails because we haven't created our solution yet. So we'll create it now. Class solution. And let's create our method as well, which we've called permutations, right? And that takes in some numbers. Let's run it again. We would expect this to say expected a big array of numbers, got back nil, right? Okay, and that's what we see our failure is. We expected to see a bunch of numbers and we got back nil. So now we're going to use recursion, and from what we've seen before, the trick to using recursion is just come up with a couple base cases and then think about what to do once we have more than the number of base cases. So with an array, usually we have like 2 base cases usually. It's when our array is empty, and it's when we only have 1 element. And then after that, we'll start using recursion. So let's do, if numbers is empty, right? Then what do we want to return? We want to return an empty array, right? Because there's no permutations if we don't have any numbers. If numbers has a size of 1, then we only have 1 number. So we're going to have an array of, I'm just typing characters all over the place. So this is the case where our numbers looks like this, for example, right? It just has a 3 in it. So our permutations is going to be an array of arrays of 1 permutation. So that means we're going to be just returning an array with the numbers parameter in it. Okay, so we've got we've got an empty numbers and we've got numbers with 1. So now we need to come up with our recursive step. So what I'm thinking we want to do is go through each number that's been provided and add to that all the permutations for the rest of the numbers. And I think that's all we need to do. So we're going to store our permutations in an array called results. We're going to store our current position at I. And then while we have a number, we will do our stuff. And then when we're done, we'll return the result. So what's the stuff we want to do? Well, we want to take our number and add it to all the permutations of the rest of the numbers. So we can just call, so I guess the first thing we have to do is get the rest of the numbers, right? So right now we have our current number. We want to get the rest of the numbers, which we'll just call the rest. And this is going to be numbers from the beginning of the array all the way to our current number, but not including it. So in Ruby, we can use the triple dot to not include the number on the right here. If we use double dot, that will include it. So we'll use triple dot. So this is going to be all the numbers before our current number. And then we want to include all the numbers after, including the last number. So see, we use 2 dots here. So this is the rest of the numbers. So now we want to get the permutations for the rest of the numbers. And for each of those, we want to add a result. So we'll push something onto our result stack, and it's going to be our current number plus that permutation. And this is actually probably, we should make this an array because we're going to be adding 2 arrays here, right? This will be like the number 1 plus 2, 3 to give us a permutation. And is there anything else we need to do? So that's going to push that result on, and then we return the result at the end. So let's try running this, see if we've got a typo or if we've not accounted for some weird edge case. Okay, it's running an infinite loop. We forgot to increment our I, right? So inside our while loop, we need to remember to increment I as well. Let's try again. Sweet. Okay, so that test passed. Let's add another couple tests in here just to make sure we don't have something weird going on. So we'll just do 2 numbers, and then maybe we'll do 1 number as well. So with 2 numbers, what do we expect? We expect 1 and 2, and 2 and 1, right? Is there any other combo? I don't think so. Let's run that. Okay, that works great. Let's try adding a test now for 1 number as well. And we would expect this to just return 1 permutation. And that works as well. Cool. I think we're done. Might have set a new record here. But we've been doing problems like this over and over and over again. So that just came out pretty easily. So here's our solution. We're going to add this to our repository. All these solutions are on GitHub if you wanted to see this problem for yourself or try it out. So we're going to add solution for today, which is the 27th. And then we'll push that up. Okay, that's it. That was a good one. We've done a bunch of these permutation problems. A lot of problems you can just turn into a permutation problem and solve that same way. You just need to find out what each permutation looks like, and your base cases will be pretty much the same. Your recursive step will be pretty much the same. You're just kind of merging things in different ways. So that's it for today. Maybe see you again tomorrow for another one. Thanks for watching. Bye.